Hi, welcome to another edition of Antique Radio Archaeology. Today we're going to begin restoration on a 1924 Chelsea Model 110 Regenerative Receiver. Now the Model 110 was paired with a Model 115 amplifier, and it was an economy radio produced by Chelsea to kind of get the working person involved in the hobby. Now, if you were to buy just the radio itself, which you could and use headphones, it was only going to set you back $17. If you wanted the additional two-stage amplifier right here, then you were going to pay an additional $16. So it was their way of kind of getting people into the hobby. This particular radio is in pretty bad shape. I picked it up for $14.50 online, and it's going to need pretty much everything to get it going. However, the case itself is in excellent shape, so that is definitely going to be a big plus in doing this restoration. Now, about a year or so ago, I did a restoration on the Model 115 amplifier, which you see here, and so I've been kind of looking for this model for a while, and finally found something that will work, and we're going to get into that here in just a second. Okay, so here we have the receiver amplifier pair as it will be when I get done. However, what you may notice is this panel looks an awful lot like that panel, and that's because it is. This is an amplifier panel. However, there's a lot of damage to this panel. Two holes here, this big chunk taken out here. So I'm not going to use this panel. I'm going to go ahead and cut a new panel and populate it for the receiver. Now, that may sound a little unorthodox. However, if you look at this panel here, on the back side of the panel it's engraved with the radio markings. So they use the same panel sometimes for either the receiver or the amplifier, depending on which way they drilled it. So while this one was drilled for the amplifier, it could have very well been drilled reversed and drilled for the receiver. So the box is exactly the same. It's just the panel itself can be flipped over and populated with whatever components it takes for that particular variation. So what I'm going to do is I'm going to go ahead and fabricate a new panel for this, and I'm going to make it into a receiver. So this will be my 110 receiver. Now the box itself is in really good shape. Like I said, it needs very little as far as restoration. This is what the amplifier looks like. Very simple, very compact, very economical. I don't see any markings on this panel, so it doesn't really tell me much. I really wish they hadn't have done this. That can be repaired, but no, that has to be repaired and that has to be repaired to make this panel functional again. Alright, so none of these parts are usable. This panel is not usable. However, I will probably try to do a repair on this. Interestingly, that hole is the transformer hole, so I need to repair those two holes, this hole, and that hole in order to make that a good faceplate for a future amplifier. Okay, so I've been gathering some parts, so we're getting there. I need to go ahead and cut this panel. So, mark this off. So this is a newer phenolic plate, which is basically what Bakelite was, only there's a lot more fiber in this. Now the problem I've got is old Bakelite has asbestos in it, so cutting it's not the safest thing in the world to do, so I prefer not to, whereas I can do that with the new plate. So let's go ahead and cut this. So this here is a variocoupler and coils out of a ZR4, and as you can see, they're a little different than the variocoupler, which doesn't have a separate coil, out of a Model 140. Now what I discovered was that the Model 110 uses the same variocoupler as the Model 140 with one exception. It mounts it to a plate like this, but this plate here is actually the same plate they use on the front of a condenser. So I found an old condenser. I went ahead and pulled the plate off of it. I can go ahead and use this variocoupler with this plate and mount it accordingly. But the problem I have is if I do that, it's going to be actually the wrong way according to the photos I've seen of the Model 110. What they've done is they flipped this around like that, but this here is actually on the top. So it's going to have to, I'm going to have to flip this over in order to get that to be able to work properly. So I'm going to go ahead and do that, and then we'll assemble this and I'll have the variocoupler taken care of. The other thing that I'm going to have to do is, I don't have the right knob for it. This here is a Chelsea knob. This is off of a selector, and I found a pointer for it. So what I'm going to do, because this doesn't have a collar that goes over a shaft like what I really need, I'm going to drill a hole through the center, thread it, and then I'm going to screw this on. I'm going to tap it and screw this on, and then I'll be able to use it that way. So that's the plan anyway. Okay, so what I did was I went ahead, after I cut that off, I went ahead and drilled a hole down through there. I tapped it to fit this. Okay, so I drilled 2 holes. Okay, so here's all the parts, got them all cleaned up. I've acquired everything I need. I've gone ahead and fabricated the variocoupler in the configuration that we need it. I've got everything else here, everything ready to go. So I have a light box here, and what I've done is when I had this thing apart back when I did this restoration on this amplifier, the back side of the panel has the lettering for the receiver. And what I did is I took a piece of paper and I rubbed over that lettering so that I could see it and find the exact location of it, which I went ahead and taped that piece of paper underneath here with a clean white piece of paper over it. And I'm going to go ahead and get the size of the panel correct here. Here are my screw holes. Alright, and as you can barely see, I can see underneath here, and I can see that this is where the lettering was. Now there is a line here, here to here. There is an arrow. You can see, barely see where those letters were. But now I've got everything transferred over to here. And what I've got to do is I got to figure out where the holes are going now for the components. So that's my next step. So using that as my template, I calculated where my holes need to be. Now I know from looking at existing models that there is a hole directly above this, and there's one right here. So I got my two good reference points. And then I needed to pretty much figure out where the center line was by folding this over, and that gives me the point at which the shaft will come through. So now I know where my holes are for this assembly. Okay, so I know that the capacitor is oriented this way in the box. Therefore, this plate goes where the capacitor goes. Now I'm going to have to clear that. Okay. So there are the holes for my capacitor. And now for the rheostat. Okay, so I did the same thing for the rheostat, made up a little paper template, folded it in half using that line there. Okay. Alright, so now I have my template. Alright, so I went ahead and dry fitted everything. It looks good. I do need to tweak a few things. I've got to countersink some holes. I've got to cut down some screw lengths, and just basically overall tweaking of some of this stuff to get it right. And then I also need to get the graphics on the front panel. So before I get going too far, one of the things I need to do is I need to fix this resistor. This came out of another radio, and this was somebody's attempt to create a variable resistor, and they failed miserably. And the reason I say that is what they did was they used regular wire. So if you sit there and measure out how many ohms this is, you're looking at, I mean, less than half an ohm. That's crazy. And so basically what this is almost a dead short. What they should have used was what's called nichrome wire. Nichrome wire comes in different gauges. This here is 0.64 ohms per foot of resistance. So this should be around 5 ohms. So I would need about 9 feet. And I don't know how much I really can wrap around here, so what I'm going to do is unwrap this wire and find out. All right. So this here is about 5 feet of wire. So if I were to use 10 feet of that, I'm not going to be able to get that all around there. Alright, so I'm going to have to go with a higher gauge. This one here is 2.5 ohms per foot times 5. That'll give me plenty to work with. So I'm going to go ahead and use this wire here. Okay, so I'm reading about 15 ohms with the nichrome wire. Okay, so I've completed the radio assembly. I went ahead and cleaned up things a little bit. I have to say, without the help of Tom Kleinschmidt, this would not be happening. He took apart his own radio to help me to figure out how this thing was wired. And it may seem like I should have been able to figure it out on my own, but let me tell you, the problem is these coils here can be wired a number of different ways. And I had to find out the way this particular radio had these coils wired, and also how certain things were hooked up. And as a result, we were able to come up with a component layout which is very accurate. I was also able to compare this to other radios that I've been able to find pictures of online. Some of them are not complete, so it was just kind of haphazard trying to figure out this part of the wiring. But with Tom's help, we were able to knock it all out. Now, a couple of things. Some radios do have a round rheostat. Some have this flat one. There's no rhyme or reason to which ones have what. And some of the bus wiring's a little different between them. So this is kind of a conglomeration of all the different ways of wiring it. But this is my wiring diagram that I use to pretty much come up with how this one got wired. Now, from the wiring diagram, we were able to come up with a schematic for it. And this is pretty much how it worked. Basically, you've got your two antenna jacks here. You've got a long-range antenna and you've got a short-range antenna. The long-range antenna here comes down and hits that capacitor. This wire here comes down and hits this capacitor. The short-range antenna comes over, hits this coil here, right there, and it comes out, and the other side of the coil comes back and hits the capacitor here. So once the signal passes through the capacitor, it's going to hit the back side of this capacitor, come back and hit this coil L3, which goes to ground. The other side of L3 is right here, comes down and hits this ground plate. The other side of this, which is over here, comes over and hits the grid leak. And the grid leak passes the signal onto the grid right here. So once that signal hits the grid, it's been tuned by this capacitor and this inductor as well as that inductor if the short range antenna is used, or directly to the antenna. And that signal is passed on through the plate. The plate circuit is right here, comes back, and I'm going to hit one side of this tickler coil. And that is tied back here. The other side of that comes over and hits the tickler coil, goes back here, comes over and hits C1 right there. It also goes down here and hits the output jack down there, which is right there. The other side of that output jack is going to come out, and it's my 45 volts right here. So that's that part of that circuit. Now for the filament circuit, I'm coming over here. I've got my wiper here tied to this filament, side of the filament. The other side of the filament comes down and hits that ground plate back here. And also there's a ground lug back there for the antenna. So that's that ground lug there. So that's the filament circuit here. And then my A plus B minus is hitting the rheostat right here. And of course I've got a minus, which is also tied to that ground plate through here. So that's it. That's the wiring of this and the schematic. And of course, signal comes in, plate circuit develops the signal, the C1 gets rid of part of the RF signal, so you've got audio passed on to your output. Now this is going to be very low output, so you can only use headphones, but of course we do have the amplifier that goes with this, and we will use that in conjunction with this for testing here in a little bit. Okay, so I went ahead and replicated that regenerative receiver little sticker that was in there. I'm going to go ahead and do it with some adhesive. Okay, so I got a 201A tube in it, and I'm going to go ahead and fire it up. Okay, don't know if you can hear it. Okay, it is working well. It's not very loud. I did hear that from Tom, that his didn't sound very loud either, so I definitely attribute that to the design. Now, it is a little harder to tune than a lot of the regens that I have, so it definitely isn't the highest in quality, so to speak, but you know, for the price at the time, it's definitely worth it. Okay, so I went ahead and got a speaker and got the amplifier hooked up, the Model 115 amplifier that goes with the 110 receiver. So I already got it turned on, just need to bring up the volume on the amp. Now, I mean, it's not the greatest, but I mean, I can't complain for the price that they would have paid back then. This is actually a pretty decent little setup, especially if you couldn't afford a speaker and amp. You could just buy the receiver and a set of headphones and still be up and running. So let's go ahead and tune in another station, but what I'm going to do is I'm going to do a close-up of the inner workings when I do that.
Directing traffic. New IQ85 trouble in the cab. There you go, Doug.
And look, yeah, that would be quite the story. Yeah, that's probably quite the fake too if you were doing that. But I got found a crash here in the left lane in the Clarkston area. A brand new at 285 South at Memorial Drive.
Okay, let's go back to the home radio station. There you have it. Wow, what a restoration. I do have to say this one was one of, I definitely would classify it as one of my more difficult restorations. There is a lot of groundwork that went into this months beforehand. I must say that, because I have been chasing this radio for a long time. Now, what I wound up getting, I didn't have a lot to work with, obviously. I just had a beat up old faceplate and a case. Had to acquire a bunch of Chelsea parts for it. And the biggest challenge was coming up with, believe it or not, the wiring and schematic for this thing. Now, there were some photos online that I was able to get access to, but none of them gave me enough detail to show me how this thing was actually wired. And it could have been wired in a few different ways. So I really wanted to make this original. So luckily, the antique radio community stepped in, was able to help me out. I was able to figure out, with the help of Tom, of course, how to come up with the proper schematic on this. Now, the biggest challenge was the variocoupler. The variocoupler on this thing could have been wired a couple different ways. Either it could have been center tapped, or it could have been two separate coils. Well, in this case, it was two separate coils, but I had no way of knowing that without Tom helping me out and actually doing the measurements on his coils. So once we got all that figured out, everything kind of came into place. Now, the next major obstacle or hurdle was, of course, the faceplate. I couldn't use this busted up one. It just really wasn't in good enough shape to be able to repair, so I did have to come up with a new faceplate. Now, unfortunately, A lot of people in the radio community would see this as no longer a restoration at this point, because replacing the faceplate is replacing a major part of this radio, and is it really a restoration at this point, or is it a new radio? I tend to believe it's still a restoration. I do intend, if I can ever come across a new faceplate, I do want to replace this one, and I will do so at that time. But in the meantime, I am considering this a restored radio and part of this collection. So, this brings this episode to a close. I hope you enjoyed it. Happy restorations, everybody. Hope to see you again next video.